How do we solve this limit? It looks pretty complex, but it's actually not. We have to first off make the distinction that x squared plus y squared equals r squared, where r is the radius of a circle. This looks something like that, where r is the radius. You should be already familiar with this. So with this, if we have to substitute into polar coordinates, which is what this is, or the coordinates of a sphere, we should know that x equals r cos theta and y equals r sine theta. So I'll explain why this makes sense. So on a graph, if we get the radius, which is r, and we have some angle theta, taking the cosine of this angle is just the adjacent side. So it'll be some point on the x-axis, and you have to multiply by r to account for that. So r cos theta, this signifies a x position. Now, if you have r sine theta, sine is just the opposite, which is the height. So the height of this will correspond to a y value position, somewhere here, and you multiply by r, of course. So let's do the substitution. Actually, no, before that, we actually have to replace this lim of xy with the limit of r approaching 0. Because think about it. On a graph, if r is, I know it's a 2D graph, but if r is approaching 0, it's becoming smaller and smaller and smaller, we're actually approaching the origin, which is what this is. 0, 0 is the origin, indeed. So let's solve this. So we have the limit of r as it approaching 0 from the positive side, because the radius is getting smaller from the positive side. We will have x cubed y, so that'll be r cubed cosine cubed theta times r sine theta over, and we know that x squared plus y squared is equal to r squared. So we would do that. Now to simplify, we will do this, limit of r as it approaches 0 from the positive, and we will multiply together. So this is r to the fourth times cosine cubed theta sine theta over r squared. Of course, this r squared cancels, so this becomes r squared in the numerator. So you get the limit of r as it's approaching 0 from the positive side, r squared times cosine cubed theta sine theta. So if we apply this limit, where we directly substitute r with 0, we get 0 times cosine cubed theta sine theta. Therefore, this implies that this limit is 0. So what this means is, given xy, the height, or like the z value, which is like the third coordinate, that goes to 0 as we approach the origin. So that's how you solve this limit.